Alright, for the last example in section 4.3, we talked about in class that we know we need to flip and change to multiplication and then factor using the grouping method for each. So I'm going to go ahead and change to multiplication, and then we know that we're going to flip that second fraction. So let's work on factoring each one. You want to come to the side, and I recommend that when you know that you're going to be doing factor by grouping, that you take it outside of the problem, factor by grouping, and then put your final answer back into the problem. So we're doing 4 terms, factor by grouping, so I'm going to separate first 2 from last 2. That's our first step. Second step is to look what's common between each term. So the first group there, I'm going to pull out 2x squared. I'll be left with x minus 5. The second group, nothing in common except for 1, and we notice that they have exactly opposite signs from what I want. So I'm going to pull out a negative 1, and then I'm going to be left with a positive x minus 5. Now remember, the third step, we don't stop there, but the third step is to pull out that common binomial factor. Pull out x minus 5, and we're left with 2x squared minus 1. Alright, so remember we want to make sure we're completely factored. X minus 5 is prime. 2x squared minus 1 is also prime. Remember that a difference of squares has to have every part be a perfect square, and 2 is not a perfect square, so that's as good as that gets. So I'm going to go ahead and write in my answer and put it back into the problem. Alright, so I'm going to take the one below it. I'm going to factor that as well. So I have x cubed minus 5x squared plus 3x minus 15. We're going to group first 2 and last 2. I'm going to pull out x squared from the first group. That leaves me with x minus 5. And I'm going to pull out a positive 3 from the second group, and that leaves us again with x minus 5. So third step is, once we see that we have that matching common binomial, we're going to pull that matching binomial out to the front, and we're going to write what's left over from each term. And notice that both of these are prime. Neither one of them is a difference of squares or a sum of cubes or a difference of cubes. So I'm going to put that right back into the problem. Alright. Now for the second fraction, we said we're going to flip the fraction, so this is going to go on top. So I'm going to factor this one, and I'm going to put the answer at the top. Alright, so I'm going to factor x cubed plus 3x squared plus 3x plus 9. I'm going to group first 2 terms, last 2 terms. So I'm going to pull out an x squared, I'm left with x plus 3. Here I'm going to pull out a positive 3, and I'm left with x plus 3. We'll pull out that common matching binomial, so I'm going to pull out the x plus 3 to the front, and then I'm going to write the x squared plus 3, the factors that are left from each term. I'm going to put that into the top. Remember we said whatever's at the bottom of this fraction will be put at the top, so I'm going to put this at the top of this fraction. So we've flipped and changed to multiplication, and now I'm factoring. So the top one here, since we're flipping it, is going to end up at the bottom after we flip. Alright. So now I'm going to factor 2x cubed minus 10x squared minus x plus 5. So we're going to group together first 2 terms, last 2 terms. We're going to pull out 2x squared. That's what's common between the first 2, and I'll be left with x minus 5. From the next group, there's nothing in common except for 1. And I'm going to pull out a negative 1 so that the terms will match in terms of signs. So that would be a positive x and then a minus 5. Pull out that common binomial of x minus 5, and we're left with 2x squared minus 1. We factor that completely, now we're going to put it back into the problem. Alright, so go outside of the problem to do the grouping. There's a tendency to accidentally stop here instead of continuing on to the final step for grouping. If you don't take it outside the problem, it's sometimes hard to see all the steps. So we factored, canceled, and now we're going to cancel identical binomials, so everything's a binomial. Now remember that if you cancel, you have to cancel something from the top and from the bottom. So I could either cancel x minus 5 and x minus 5, one's at the top and one's at the bottom, or I can cancel x minus 5 and x minus 5. It does not matter which two that you cancel as long as one's on top and one's on the bottom. So I'll just cancel these. We have a 2x minus 1 here and a 2x minus 1 here. We have an x plus 3 here and an x plus 3 here. So if I multiply across, technically I'm left with 1 and 1 for all of this. And if I multiply across, 1 times x plus 3 is x plus 3. 1 times x minus 5 is x minus 5. So this would be our final answer, and it's reduced to lowest terms.